All right, everyone get ready because today we're going deep into fermentation.
Oh, yeah.
And,
The wonderful world of fermentation.
exactly from that like tangy sourdough bread that we love
Mm-hmm.
to a good beer, after a long day.
Absolutely. It's everywhere.
It is everywhere, and it's so ancient, it's
Mm.
complex, and it all comes down to these small microbes,
Yeah.
these tiny chemists.
Nature's tiny chemists. Yeah.
Exactly.
It's fascinating to me because it's not just about, yummy food and drinks.
Yeah.
This is like a biochemical process.
Yeah.
And it could really revolutionize how we make, fuels
Yeah.
and even medicine.
Yeah, and it's so fascinating.
Mm-hmm.
I was reading that scientists are looking to these ancient fermentation techniques
Really?
to develop new biofuels.
Wow.
And it's like we're going back to the old ways
Yeah.
to solve.
It's a full circle kind of thing.
Yeah, exactly.
It makes sense though if you think about it. Yeah.
Our ancestors were already using the power of these little microorganisms
Right.
to change raw materials.
Yeah.
They didn't have like the scientific tools that we have
Right.
to figure out the mechanisms.
Yeah.
But today we can identify specific, bacteria,
Uh-huh.
yeast, and we can manipulate their little pathways
Yeah.
to produce, bioethanol, biodiesel, all these biofuels.
It's like taking these microscopic factories and
Of
like
course.
supercharging them
Exactly.
to create this renewable source of energy.
Yeah, that's a great way to put it.
But when we talk about control, right?
Mm-hmm.
I'm curious about controlled fermentation
Yeah.
in other industries
that's
like food and pharmaceuticals.
Yeah.
How do they ensure that
Consistency.
that safety?
So in the pharmaceutical industry,
Yeah.
controlled fermentation is super important
Okay.
for producing medications, like insulin
Mm-hmm.
or certain antibiotics.
Mm-hmm. Oh, wow.
You need very specific conditions
Right.
to make sure that the microorganisms
Yeah.
are producing the right compounds
Uh-huh.
in the right amounts.
Okay.
It's this like delicate dance between biology and engineering.
It makes you realize
Yeah.
that even the smallest change in temperature
Right.
or pH
Of course.
or nutrient availability
Yeah.
could really affect the final outcome.
Exactly.
It reminds me of the fact that our liver
Oh yeah.
has its own circadian clock.
It does.
And it affects how our bodies
Uh-huh.
metabolize drugs at different times of the day.
That is fascinating.
Yeah.
It really highlights how important timing and control are.
Yes.
Both in our bodies
Mhm.
and in these fermentation processes.
Yeah.
It's like our internal clocks regulate our metabolism, right?
Uh-huh.
And precise control over fermentation determines the quality and characteristics
Yes.
of the final product.
Yeah. So think about like, a light crisp lager
Mm-hmm.
versus like a rich full-bodied stout.
It's amazing
Yeah.
how these subtle variations in the fermentation process
Right.
create such a variety of flavors
Totally.
and aromas.
Absolutely.
It really makes you appreciate
Yeah.
that artistry
Yeah.
that goes into it.
I think when it comes to artisan food production,
Mm-hmm.
skilled producers are essentially collaborating with these microbial communities.
Oh, interesting.
They understand how things like temperature,
Hmm.
humidity,
Huh.
and the types of microorganisms
Right.
are going to influence the final flavor.
That's so cool.
Yeah.
It's like they're conducting a microscopic orchestra
Yeah.
to coax out these unique flavors and texture
I like that.
from these invisible collaborators.
Uh-huh.
And sometimes
Yeah.
even a little imperfection can enhance that final product.
That's right. Think about,
Yeah, like what?
like blue cheese
Oh, yeah.
with those distinct veins
Mhm.
of mold.
Yeah.
Those are actually specific strains of fungi
Okay.
that contribute to the aroma and
Yeah.
the flavor.
Yeah.
And the FDA, they have what's called action levels
Oh, okay.
for certain contaminants in food.
What are action levels?
So basically they recognize that absolute purity is kind of unrealistic,
Right.
especially when you're dealing with natural ingredients.
Yeah, that makes sense.
So these action levels, they specify acceptable limits
Okay.
for things like,
Okay.
insect fragments
Okay.
or rodent hairs
Oh,
in food.
so they're basically saying
Yeah,
that a little bit of imperfection
a little bit.
is is a
It's not only acceptable, but sometimes even desirable.
It's about balance then.
It is. It's finding that balance between
Right.
safety and authenticity and these naturally occurring
Yeah.
elements often indicate a less processed,
Right.
a more natural product.
So it's a reminder
Yeah.
that embracing those little imperfections
Yeah.
can actually enhance
For sure.
the flavor and the character
Absolutely.
of what we eat.
Yeah, I mean, who knew?
Yeah.
The FDA was so into little wildness
Yeah, exactly.
in our food.
A little funk.
Little funk. But of course, you know, we always have to remember
Right.
that food safety is paramount.
Of course.
Yeah, that's the FDA's role,
Right.
you know, is to make sure
Yeah.
that those imperfections don't actually pose a health risk.
It's a fascinating balancing act.
It is.
And they're kind of acknowledging
Yeah.
that a certain level of, let's say, microbial diversity
I like that.
can contribute to
Yes.
the quality and the character
Yeah.
of our food.
That's a great way to put it.
And it's this very microbial diversity
Yeah.
that's driving so much innovation
Yeah, absolutely.
in the world of fermentation.
Oh,
I
yeah.
can't wait to learn more about that.
Let's get into it. Welcome back. You know, we were just talking about how the FDA embraces
Yeah.
a certain level of microbial diversity
Yeah. It's fascinating.
in our food.
It is to think about how those action levels
Yes.
really change how we look at
Right.
what's pure when it
Right.
comes to what we eat.
Totally.
But I'm also really interested in how scientists are using fermentation
Right.
to create sustainable biofuels.
Yeah. Yeah.
It sounds almost too good to be true.
It does. It does.
Like we can actually fuel our cars
Yeah.
with the help of these
Right.
microscopic powerhouses.
It's not magic.
Oh,
It's science.
Yeah.
And it's becoming more and more important
Yeah.
as we look for alternatives to fossil fuels.
Oh.
You know, think about it. These biofuels like bioethanol, biodiesel,
Okay.
they're really harnessing the energy
Great.
that's stored in plant matter.
Yeah.
And fermentation is the key.
So it's like we're unlocking that, tapping into this ancient process
Exactly.
to address this challenge.
Yeah.
Our dependence on fossil fuels and
Yeah.
the impact it has on the environment.
Yeah.
What are the biggest hurdles to making this a reality on a large scale?
Well, one of the key challenges is
Yeah.
finding the right microbial candidates.
Okay.
So the specific strains
Mm-hmm.
of bacteria and yeast
Yeah.
that can efficiently convert that plant matter
Okay.
into usable fuel. So that it's not, you know,
Now one size fits all.
one size fits all.
Yeah.
Different feedstocks,
Right.
like corn stalks or sugarcane,
Right.
require different microbial communities.
So it's like matchmaking.
It is. It's like matchmaking.
Yeah. Finding a perfect microbial partner for
Exactly.
each type of plant material
Yeah.
to get the best results.
And on top of that,
Okay.
scientists are always working to optimize the fermentation process itself.
Right.
It's this balancing act. You need the right temperature, pH, nutrient balance, even oxygen levels
Okay.
to make sure those microorganisms are thriving.
It's like orchestrating this microscopic symphony.
It is.
Yeah.
Making sure all the
Making sure all the instruments are in tune and playing their part
throwing their parts perfectly.
perfectly.
Yeah.
And are there specific types of
There's-
biofuels that are showing the most promise?
Well, bioethanol,
Okay.
which is, you know, typically produced from corn or sugarcane, that's
Mhm.
already being blended
Oh, wow.
with gasoline in a lot of countries.
Okay.
But there's a lot of excitement
Yeah.
around advanced biofuels.
Advanced biofuels, what are those?
So these are biofuels that can be made from non-food sources, like
Right.
agricultural residues or
interesting.
even algae.
So we're talking about like the corn stalks,
Yeah.
wood chips instead of the actual corn kernels.
Exactly.
Okay.
Yeah, and these advanced biofuels have the potential
Yeah.
to reduce greenhouse gas emissions
Right.
even further than traditional biofuels.
It's incredible to think that these tiny microbes
Okay.
could play such a big role
Yeah.
in making a more sustainable future.
I know.
It makes you realize how much potential there is
Right.
locked away in the microscopic world.
There is. It's not just about biofuels.
Okay.
Fermentation is also being used to create a whole range of other
Okay.
bio-based products,
Okay.
from biodegradable plastics to sustainable textiles.
So we're moving towards a future
I think so.
where we're relying less
Yeah.
on petroleum-based products and more on these
Wow.
renewable.
Precisely. It's like a shift towards a bio-based economy
Interesting.
where we're using the power of nature to come up with more sustainable solutions.
That's really exciting.
It is. It is.
But, we've been talking a lot about these industrial applications of fermentation.
Of course.
What about the more traditional
Yeah.
uses in food production?
Right.
What's going on in that area?
Well, one area that I think is really cool
Yeah.
is the rise of artisan fermentation.
Artisan fermentation.
Yeah.
I love that.
Yeah.
Those small batch cheeses
Exactly.
and fermented vegetables
Yeah.
that you just can't find in a regular supermarket.
Right.
What makes them so special?
It often comes down to the specific microbial cultures they're using and the unique fermentation conditions that they create. For example, some cheesemakers are experimenting with wild in their local environments.
That's so cool.
Which give like really unique flavors to their cheeses.
So they're capturing those wild microbes.
They are.
And putting them to work.
Yeah, they're cultivating.
They're cultivating
a little
ecosystem of flavor.
Ecosystem of flavor.
In their cheesecake.
Exactly.
And it's that attention to detail.
Yes.
That deep understanding of how microbes and ingredients work together.
Yeah.
That sets artisan fermentation apart.
I think so.
It reminds me of something you said earlier.
What's that?
About how those action levels for contaminants show that a little imperfection can be a good thing.
A little bit.
Yeah.
Can be a good thing.
These artisan producers are embracing those imperfections.
They're not afraid.
And using them to create something.
A wild microbe.
Unique and flavorful.
Do their thing.
Yeah.
Even if it means, their products might not look perfectly uniform, or have a slightly funky aroma.
It's a celebration of the natural world.
It is
the diversity of flavors that those microbes can create.
Yeah.
But I'm curious, how are scientists contributing to these advancements in
artisan fermentation? Well, while there's certainly an element of intuition and artistry, science is playing a bigger and bigger role.
Okay.
Researchers are developing new tools to analyze microbial communities, identify beneficial strains, and optimize those fermentation conditions.
So they're giving these artisan producers a deeper understanding of the science behind their craft.
Yes.
And this collaboration between science and tradition is leading to some really remarkable innovations in fermented foods. For instance, scientists are helping to develop new starter cultures that can produce specific flavor profiles or improve the nutrition of those fermented products.
It is.
It's like a delicious marriage of art and science.
It is a delicious marriage.
And to think it all comes back to those tiny microbes. I'm starting to see them as these invisible artists shaping the flavors and textures of our food and even helping us create a more sustainable future.
They are. They truly are.
They truly are.
And as we, keep uncovering the secrets of the microbial world, who knows what other wonders we'll discover.
It's an exciting journey.
It is.
And I'm eager to see.
Me too.
Where it takes us.
Yeah.
Speaking of journeys, I think we've reached the end of part 2.
Oh, okay.
Of our deep dive into fermentation.
Right.
But don't worry, we'll be back for part 3 to wrap up this delicious and insightful exploration. Welcome back to our deep dive. We've talked about a lot.
We have.
From those ancient fermentation techniques to the cutting-edge science that's being used to create biofuels.
Right.
And even those artisan cheeses with those unique flavors.
Absolutely. It's been quite a journey.
It has been, and through it all,
we
keep coming back to these incredible microorganisms.
It always comes back to the microbes.
The bacteria and yeast that make it all possible.
Right?
They really are the unsung heroes.
They are the little engines that could.
It's so true.
Yeah.
When you think about it, fermentation is this really complex process.
It is.
That's been going on for millennia.
Right.
But it's only recently that we've really started to understand the science behind it.
Appreciate it. Yeah.
Yeah, the interplay of biology and chemistry that these microbes orchestrate.
It's like we've been enjoying the symphony for centuries without really understanding the musicians or the instruments. And now we're finally starting to appreciate the complexity of the score and the skill of the conductor.
And as we learn more about these microbial communities, we're gaining more control over that fermentation process.
We are.
It's like we're learning to speak their language.
Totally.
To nudge them in specific directions. To create the flavors and textures we want.
Like, think about those artisan cheesemakers.
Yeah.
You know, they're really collaborating with these microbial communities.
Yeah.
Creating the perfect conditions for them to thrive and produce those unique flavors.
Is that dance between
human ingenuity
and the natural world.
A delicate dance.
And it's happening on a much larger scale too. Right. Like with those biofuels we talked about.
Yeah.
We can harness the power of these microorganisms to address these environmental challenges.
It's pretty amazing.
It really is. And it speaks to their versatility.
It does.
They can help us create everything from food and beverages to sustainable fuels and even life-saving medication.
Oh, no, it's incredible.
But are there any downsides?
That's a good question.
Or challenges that we should be aware of?
Well, you know, fermentation itself is generally safe. And beneficial. But there are a couple things to keep in mind.
Like,
so, for instance, some fermented foods can be high in histamine, which can, trigger allergic reactions in some people. And, of course, with any food production process, there's always a risk of contamination.
Of course.
If proper hygiene and safety protocols aren't followed.
So it's about being mindful and informed.
It is, as with anything else we consume.
Right, yeah.
You know, it's important to get your fermented products from reputable producers who prioritize safety and quality. And if you're new to fermented foods, it's always a good idea to start slowly and see how your body reacts.
That's good advice as we wrap up this deep dive.
Yeah.
I'm just in awe at the power and the potential of these microorganisms.
It is pretty remarkable.
They've been shaping our world for millennia.
For so long.
And we're only just starting to understand what they can do.
I know. There's still so much we don't know about the microbial world.
Yeah.
So many secrets waiting to be unlocked. And as we, keep exploring and experimenting, I'm sure fermentation will continue to surprise us.
It's a reminder that sometimes the most profound transformations happen
at the microscopic level.
At that microscopic level, driven by
these tiny but
mighty organisms. And I think the most important takeaway from all of this
what's that?
Is that we're not just observers of this microbial world.
Right.
We're active participants.
We are.
Our choices, from the foods we eat, the fuels we use, can shape the microbial communities around us.
They can.
And those communities, in turn, shape our world.
That's a really powerful thought.
It is. It makes you realize that fermentation isn't just a scientific process. It's a collaboration.
It is.
A partnership between humanity and the natural world.
I love that.
And as we learn and innovate, I'm excited to see what new possibilities this will bring.
Yeah, it's a journey filled with flavor, sustainability, and maybe even solutions to some of humanity's greatest challenges.
Well said. And on that note, we've reached the end of our deep dive.
Oh, wow.
Into this magical world of fermentation.
It has been magical.
It has been. We hope you've enjoyed it as much as we have.
Yeah, thanks for joining us.
And until next time, keep exploring.
Yeah.
Keep experimenting.
Yeah.
Experimenting.
And keep marveling.
Keep marveling.
At the wonders of the microbial world.
Absolutely. See you later.